Okay, this is the last topic in this chapter, and then once we complete this topic, there's a handful of practice problems at the end of the slideshow that I will also work through. So storic enamine reactions are really cool. They're using an enamine as a nucleophile, which is completely analogous to using an enol or an enolate nucleophile. So for example, if you take a ketone and you add in a secondary amine, this is para-toluene sulfonic acid. This is going to be our acid catalyst. Remember, enamines are made in the presence of acid typically, so you just have a small amount in there. It's an acid that would not be able to create like any sort of nucleophile or any sort of target for the enamine. So once you have the enamine, notice that it has a structure very, very similar to an enolate. You can imagine, not having this anymore and having the oxygen there. It's a very similar idea, and therefore it has pretty similar chemistry. And then we also have this resonance form where you can take these electrons and create a pi bond in between the nitrogen and the carbonyl carbon, and you could push these pi electrons onto the alpha carbon, and now it really looks like an enolate, right? We have a nucleophilic carbon and a nitrogen that's like, it's not happy, but it's not unhappy. So if we take the enamine that we made on the previous page, we can actually push these electrons out to have them act as a nucleophile. And a nucleophile in the presence of an acyl chloride is going to want to attack that carbonyl carbon. That's going to give us a tetrahedral intermediate. And from the tetrahedral intermediate, we can kick out the chlorine. So we've managed to put an acyl group in the alpha carbon position, which is pretty cool. We haven't seen that happen yet. So the storic enamine reaction gives us some pretty cool options for synthesis. It allows us to make connections between carbons that otherwise we would not be able to. So for this one, what you have to do is decide which structure am I going to make an enamine from and which one is going to be my target. And before you can do that, you have to figure out how are these two connected. So this carbon in our product has to be this carbon on acetophenone. This carbon is alpha to the carbonyl on cyclopentanone. So both of these carbons that we've highlighted are alpha carbons, which means either one of these could be turned into the enamine if we wanted. But since the enamine did not end up attacking a carbonyl directly, that means we also have to take the other compound and add a leaving group of some sort. So that would mean alpha halogenation. What I would recommend is anytime you want to create a leaving group and you want to have a lot of control over it, typically you choose one that's not going to have a lot of options. So I would probably take acetophenone and do the alpha halogenation. So if I take acetophenone and I react it with, let's say, one equivalent of molecular iodine and one equivalent of hydroxide. So one equivalent of each. I'm going to end up putting a halogen, one iodine on the alpha carbon. So now if I make an enamine out of cyclopentanone, it's going to be able to attack this carbon and I can get to my product. So I'm going to take cyclopentanone and I'm going to make an enamine. It doesn't really have to be, any specific secondary amine to do this. So you could use a cyclic one if you wanted, but you do not have to. So now I have my enamine, and I can bring these electrons down, use these to attack. And I'm going to keep color coding just in case that's helping anybody. Here's my new bond that I made. And that bond is going to be made to cyclopentanone. And now I have an iminium ion. So if I want to get to my product, the only thing left for me to do here is to remove the iminium there to undo the enamine. And you might recall back from a couple chapters ago, you can put an imine or enamine on, and then you can hydrolyze it back to the ketone. So that's all you'd have to do for this. And honestly, you could have done it either way. You could have halogenated the alpha carbon on the cyclopentanone and then made an enamine out of acetophenone. Either way would work in this situation, not always.